Okay, so far we've looked at function notation, but we've done it very visually with mappings or sets of ordered pairs or graphs. Now we're going to look at maybe the most common application of function notation, and that's with an equation. Okay, so let's recall first of all function notation. You write your function name, maybe it's f or g or h, whatever, f of your input x, and that equals y. So f of your input equals your output, okay? F of your input equals your output. So let's assume that we have some function defined using this equation, okay? And we'll do some analysis of this. So let's assume that f of x equals a fraction, 2x squared minus 3 over x minus 4. Okay? Now, this is a formula to define this function. It's not a visual representation to tell you that, well, this input has this output. It tells you a generic formula to calculate outputs for any input. Okay? So what this is saying is that the way you use a formula is you change the value of the variable to be whatever you want, and then that variable takes that value everywhere. So our variable here is our input x, okay? And so the key is anywhere there's an x, that's the variable part of this equation. That's the variable. F is the function name. That doesn't change, right? That's not a variable. That's the name of this machine for which we can put inputs in and receive outputs. So whatever this x is, both of those x's are the same, okay? Those are both the same. So you can kind of think of this as, don't get hung up on x. Don't get hung up on x. We use x because that typically represents input in algebra. But just think of it as a machine f with this chute, right? This is just like a hole to the machine, and you can put whatever you want into that hole, right? Whatever input you want, put into this chute, which is going to feed it to the f machine. And it's going to output, remember, f of this input, whatever that happens to be, that whole thing is what your output is. And so the output of this is going to be 2 times the input, whatever it is, squared minus 3 over the input minus 4. Okay, don't get hung up on x, okay? It just means input, and it can change. It's a variable. So whatever you feed into the f chute, it's going to come over here into both of these places and form a calculation to give you a final number output. Now let's do a particular example with this function where we actually calculate an output. So let's do an example. Let's see if we can determine the value of f of 2. And so what this means is f of 2 means y value. It means output. So what we need to do is, since 2 is in parentheses, we know that's the input. We need to input 2 to this function. And by the way, whenever you see f of x equals like this, whenever you see that, that is the definition of the function. So in this case, it's the definition of f. It's very important to understand that. This defines your function. Just like a picture of a mapping defines what the function does to an input. Same thing here. This is how you calculate outputs for the function f. So f of 2 means plug 2 in for x, right? And that means I have to replace all of my x's with 2. That's my input. Or 2 goes into the chute as the input to the f machine, and then it goes in these spots in my output. Now it's important to know your order of operations when you do this. So for example, when I say 2x squared, you have to understand what that means. It means you square x, whatever it happens to be, whatever number you're plugging in, you square that first, and then you multiply it by 2. That's why the parentheses are extremely important here when you plug in an input. If you're not sure about the order of operations, put parentheses around your input every time, and that should help, okay? So if we do that here, it looks like 2 times 2 squared minus 3 over 2 minus 4. And then using the order of operations I already mentioned, if I square 2, I get 4. 4 times 2 is 8. 8 minus 3 is 5. So my numerator's 5. And on bottom, 2 minus 4 is negative 2. So 5 divided by negative 2 is negative, it's a negative fraction, negative 5 halves. So that's typically how we write that. You could write negative 2.5. Often fractions are preferred, improper fractions, not mixed numbers. Now, what does this mean? This means that if we take the input of 2 and we input it, right, 2 is the input, to the f function or the f machine. Think of this as a machine that has inner workings. If we input 2 to that and 2 goes through these inner workings, all of this happens and the machine finally outputs negative 5 halves. Okay, so that's kind of a visual way to think of this. And that's how you calculate outputs for any input with this particular function. Now let's practice some more function notation with equations. And we'll try to throw in some examples of commonly missed algebraic calculations. And that's kind of what's tricky about making a video like this is I can't cover all the possible calculations you should know how to do. So I'm going to try to pick on the ones that a lot of people have trouble with or miss frequently. So here are some functions. F of x, let's say, is 3x squared minus 2x plus 1. It's a polynomial. It's a trinomial, actually, because it has 3 terms. Lots of different things we could say about this. G of x is negative 2 times a vertical bar. And inside the vertical bars, I have, let's say, 3x minus 5. So I've got 3x minus 5 inside these vertical bars. We'll talk about those in a minute, plus 4. So do you remember what the vertical bars mean in mathematics in this particular case? It means what's called absolute value. So we'll see how to handle that in some cases. If you don't remember absolute value, you might want to go do some reading up on it. All right. Last, let's say we have h of x equals negative 17. Such a simple function, but because it's so simple, it can be confusing. Let's do examples now. Let's consider f of negative 5. So that means negative 5 is input to the f function, which when it's an equation, that means, well, here's x. That means these x's have to match that x. So I need to replace these x's with negative 5. So we've got 3 times negative 5 quantity squared minus 2 times negative 5 plus 1. Well, this is 3 times 25. That's 75. Minus 2 times negative 5 is negative 10. So I've got minus negative 10, which of course is plus positive 10, and then plus 1. So I've got 75 plus 10 plus 1, which is 86. So if we input negative 5 to the f function, it outputs 86. If x is negative 5, y is 86 for the f function. Okay? So that's one example with the f function. Let's do another. Let's look at g of negative 6. So now I go to my g equation and I substitute negative 6 in for my input, so this x also turns into negative 6. So we've got negative 2 times the absolute value of 3 times negative 6 minus 5, close the absolute value, plus 4. So when we have absolute value, we treat it kind of like parentheses. We figure out everything inside first. So 3 times negative 6 is negative 18. Negative 18 minus 5 is negative 23. Keep your absolute values. We haven't dealt with those yet. And keep everything else as well. So now the next thing I need to do is I need to multiply negative 2 by whatever this is. So I need to know what the absolute value of negative 23 is. And the absolute value of negative 23 is positive 23. Again, use your order of operations. So now this turns into negative 2 times. So my absolute value bars turn into parentheses. Negative 2 times positive 23 plus 4. So now we've got negative 46 plus 4 is negative 42. So g of negative 6 equals negative 42. If we input negative 6 to the g machine, the output is negative 42. All right, let's do another one. Let's go to the h function. Let's look at h of 4.1. That means my input or my x value is 4.1. So any place there's an x, I replace with 4.1. Here, the output does not involve x at all. It's completely independent of your choice of x. So no matter what x is, the output here is negative 17. And it's that simple, okay? So h of 4.1 equals negative 17. And no matter what you plug into this function, your output is negative 17 because x is not involved in the calculation at all. All right, let's do 3 more quick examples applying each of these functions with a variable input. Okay, let's look at f of, now let's say the input is x plus 1. Don't be scared by this. All this means is the input is x plus 1, meaning I look at my definitions. Well, I go to my f definition, which is right here, and I replace all of the x's with x plus 1. So this turns into 3 times the quantity x plus 1 squared minus 2 times the quantity x plus 1, right? I'm replacing both of those with x plus 1 plus 1. And then I just simplify this. Now I'm not going to get a number as my answer. My answer is going to involve x because my input involved x as well. All right, so first thing I need to do is square x plus 1, which that means x plus 1 times x plus 1. If you need to write that out, x plus 1 squared means x plus 1 times x plus 1, and you should be able to multiply that pretty easily. But when you do, you get x squared plus 2x plus 1. If you don't remember how to do that, you may need to do some research on x plus 1 times x plus 1. You just simply distribute all of this out, okay? Then here, I've got minus 2 times x plus 1, so I need to distribute my negative 2 and then bring down my plus 1. All right, and then in the end here, we have one more step. We'll distribute our 3, and I'm going to go ahead and combine like terms. So I've got 3x squared. That's my only x squared term. Then I've got 6x, but then here I've got minus 2x. So that's plus 4x. And then last I've got 3, but then I've got minus 2, which is, so 3 minus 2 is 1. 1 plus 1 is 2. And I can't simplify it any further. I've gotten rid of all my parentheses and combined all the like terms. And so if I input x plus 1 to this function f, the output is 3x squared plus 4x plus 2, okay? We could do the same sort of thing with the other two functions. In fact, I think that's good enough. You should be able to input numbers to these functions or expressions, right, with variables themselves. And it's no big deal. It's the same process. Just plug in whatever this is, plug it in as your input, which means replace all the x's with that expression.